Welcome to the DIY Honda Garage channel. DTC P0328 indicates there is a high voltage detected in the knock sensor 1 circuit for bank 1 in a Honda Pilot manufactured between 2016 and 2022. The knock sensor's primary role is to monitor engine vibrations, specifically detecting knocking or pinging that indicates abnormal combustion, which can affect engine performance and longevity. In this vehicle model, the knock sensor is usually located on the engine block, typically near the cylinder head. Upon detecting an abnormal voltage level, the Engine Control Module, PCM, triggers this Diagnostic Trouble Code, DTC. This code is crucial as it may lead to performance issues if not addressed, potentially causing engine damage. Clearing the DTC and checking for its reoccurrence is the first step to confirm whether the issue persists, which is vital for effective troubleshooting. The knock sensor 1, located on bank 1, plays a vital role in monitoring engine vibrations. Its function revolves around detecting vibrations associated with knocking, a phenomenon that can lead to engine damage if not controlled. This sensor is typically affixed to the engine block, specifically close to the cylinder head, making it well-positioned to perceive the vibrations from the combustion process. The data it collects is then relayed to the PCM, or Powertrain Control Module, which uses this information to adjust ignition timing and fuel delivery accordingly. When the voltage level from this sensor is too high, it triggers DTC P0328. The identification of this DTC is crucial, as it subsequently directs the diagnostic process, allowing technicians to determine if there's an actual sensor failure or an issue within the wiring and connections of the system. Several potential causes for DTC P0328 have been identified. A common issue is a faulty knock sensor, which may fail due to age or physical damage, leading to incorrect readings and high voltage signals. Poor connections, particularly at the knock sensor or the PCM, can also result in intermittent failures that trigger this DTC, as loose terminals can disrupt the flow of data needed for guaranteed operation. Wiring issues, such as frayed or broken wires within the KSB1/KSB1 line, can also contribute to the high voltage readings by affecting the electrical current paths. When diagnosing, it is imperative to examine these areas closely to determine the source of the problem. By understanding these potential causes, technicians can streamline their troubleshooting efforts more effectively. The symptoms associated with DTC P0328 are noteworthy indicators of underlying issues within the engine's performance dynamics. One of the most prominent signs is the illumination of the check engine light, CEL, drawing the driver's attention to a potential problem with the vehicle's systems. This light won't appear without reason, as significant issues usually precipitate its activation. Drivers may also notice poor engine performance, including reduced power or responsiveness, affecting the overall drivability of the vehicle. Additionally, abnormal engine noises, such as knocking or pinging, could be perceptible, indicating that the engine is experiencing irregular combustion. Identifying these symptoms quickly and addressing the root cause can prevent further damage and improve the vehicle's performance. The first step in troubleshooting DTC P0328 requires verifying the issue. Begin by turning the vehicle to the on mode without starting the engine, which powers up the electrical systems for diagnostics. Utilizing an HDS or Honda Diagnostic System, clear any existing DTCs, including the P0328. This action is vital as it resets the engine parameters and allows for an accurate assessment of the system's current state. After clearing, turn the vehicle back to the off or lock mode, then re-engage the on mode again. Following this, check for any pending or confirmed DTCs using the HDS. If DTC P0328 reappears, it confirms that the issue is persistent and indicates that further investigation is needed, following the subsequent steps in the troubleshooting process. The second step focuses on identifying the potential failure area concerning knock sensor 1 on bank 1. Start by turning the vehicle to the off or lock mode, ensuring that all electrical systems are powered down for safety. Carefully disconnect the knock sensor 1 2P connector, which houses the electrical connections for this specific sensor. Once disconnected, switch the vehicle to the on mode again, allowing electrical systems to engage without the sensor being connected. It is during this stage that you'll measure the voltage between the test points within the connector using a multimeter. Specifically, you will check between points 1, female terminal number 1, and 2, female terminal number 2. If the voltage reads approximately 5.0 volts, it indicates that the sensor is faulty and requires replacement. If not, you will need to proceed to the next step to further diagnose the circuit. In this step, the focus shifts to checking the KSB1 line for faults. By keeping the vehicle in the on mode, you'll again ensure the knock sensor 1 2P connector remains disconnected to ensure an accurate reading. Using your multimeter, measure the voltage between the designated test points. These are test point 1, female terminal number 2 of the 2P connector, and a solid body ground. A reading of about 5.0 volts at this juncture indicates that the KSB1 line is functioning correctly. If the voltage reflects this value, you can confidently move to step 5, shifting your attention to verify the continuity and functionality of the wiring. Conversely, if the voltage is not as expected, the next course of action is to delve into troubleshooting for potential wiring issues or other component failures. Step 4 investigates the wiring integrity along the KSB1 line by completing an open wire check. Initiate by ensuring the vehicle is turned to the off or lock mode to safely verify the electrical circuits. Utilize the HDS to jump the SCS line, a procedure that partitions the system by essentially resetting it and requires you to wait for more than 1 minute. After this preliminary setup, disconnect the PCM connector E, ADP, to perform a continuity check. Measure between the designated test points, point 1, which should be female terminal number 2 of the knock sensor 1 connector, and point 2, which corresponds to the PCM connector E at pin number 52. If continuity exists, the wiring is in good condition, and the troubleshooting should then shift towards inspecting for any relevant service information or substituting with a known good PCM as a next step. If continuity is not present, repair any open circuits along the identified line. The concluding troubleshooting step involves examining the KSSGB1 line, which has a critical role in the knock sensor's functionality. Much like in Step 4, begin by switching the vehicle to the off mode to safely perform an open wire check. Jumping the SCS line with the HDS must occur first, followed by waiting for over a minute to clear any outstanding errors. Next, disconnect the PCM connector E, ADP, for proper isolation during the test. Measure continuity across the designated test points again. From point 1, female terminal number 1 of the knock sensor 1 connector, to point 2, PCM connector E at pin number 51. A positive continuity indicates that this wiring is intact, prompting you to consult for authorized service information regarding the symptoms or DTCs. Conversely, should continuity not be present, you must repair any open circuits present in the KSSGB1 line to ensure reliable knock sensor performance. Upon completion of repairs stemming from the troubleshooting steps, it is essential to perform a final verification. This process kicks off with rechecking for any DTCs using the HDS to confirm that the issue has indeed been resolved. If DTC P0328 does not return upon rechecking, a significant success has been achieved in rectifying the original fault. However, a test drive of the vehicle is crucial. Driving under various conditions allows the technician to observe if the vehicle performs satisfactorily without any abnormalities. If no CEL illuminates or performance issues arise during this test phase, it solidifies confidence in the repair's success. Proper verification steps ensure customer satisfaction and vehicle reliability, reducing the likelihood of repeat issues down the line. While specific preventive maintenance measures for DTC P0328 may not have been highlighted in the troubleshooting guide, general practices can substantially mitigate such issues. Regular inspections of the knock sensor and associated wiring can help detect potential failures before they escalate into a serious problem. Visual inspections to ensure connectors are secure and wires are not frayed or damaged are crucial for maintaining the system's integrity. Cleaning contacts and connections periodically can also promote better electrical flow and performance. Additionally, monitoring the health of the engine sensors will allow for timely replacements or repairs, ultimately prolonging the life of the vehicle's components. Proactive maintenance is essential in ensuring optimal vehicle performance and preventing future DTC occurrences. In conclusion, understanding DTC P0328's significance is crucial for maintaining vehicle performance. This specific code serves as a warning from the vehicle's onboard diagnostics, indicating potential issues with the knock sensor's functionality. Following a systematic troubleshooting approach, from verification to continuity checks, provides a clear pathway to identifying the root cause of the code. Effective diagnostics not only assist in resolving immediate concerns, but also emphasize the importance of routine inspections and preventive maintenance practices. By maintaining an awareness of wiring integrity and sensor health, future complications can be avoided. Overall, addressing DTCs promptly is vital for the longevity and reliability of the vehicle, ensuring a safer and more efficient driving experience. Please like and subscribe to the channel. See you next time.